Hello everyone. Today we'll be going through section 4.2 of Pure Math 2. This video will follow the exact same structure as my video on the product rule, except today we'll be going through the quotient rule for differentiation. We'll go through the rule itself, situations where you would apply it. We will prove it using the first principles of differentiation, and then I'll go through a quick example actually differentiating a function using the quotient rule. Now, when we're using the quotient rule similar to the product rule, we're considering a function that's composed of two separate functions, except this involves division rather than multiplication. We're going to consider some function y is equal to f of x divided by g of x, or if you want f of x to be equal to u and g of x to be equal to w, you could consider y being equal to u divided by w. For the rule itself, we have that the derivative of y with respect to x, or y prime, is going to be equal to f prime of x multiplied by g of x minus by g prime of x multiplied by f of x, all of that divided by g of x squared. So we can see that this follows a similar structure to the product rule in terms of the fact that we have the derivative of one function multiplied by the other function, and then we have the derivative of that other function multiplied by our first function. Except in this case, the ordering of our functions actually matters because we have a minus symbol here rather than just a plus. And we also have the denominator becoming squared. Another way you could look at this with u and w instead is that the derivative is equal to w multiplied by du over dx minus by u times dw over dx, all of this divided by w squared. Now, in order to remember the quotient rule, the first thing that we'll want to remember is that our denominator becomes squared. And that's a fairly simple thing to remember, but the difficult thing sometimes can be remembering whether you're subtracting by a function being multiplied by the derivative of the denominator or the derivative of the numerator. And to remember this, all that you need to know is that the first function that gets differentiated is always the numerator. So the first function that gets differentiated is always the numerator. And then this is, of course, multiplied by the denominator. And then the function that gets subtracted is the one where we are differentiating the denominator. And of course, this is multiplied by the numerator. So numerator times denominator, and denominator times by numerator. And then you just have to remember that this entire thing is divided by our denominator squared. An example of a function that we would differentiate using the quotient rule is this over here. Y is equal to 4x cubed minus by 8, and then that's divided by the square root of 9x plus by 1. In this case, of course, f of x would be 4x cubed minus 8, and g of x would be the square root of 9x plus 1. Now next up, I would like to prove the quotient rule using the first principles of differentiation. And this will follow the same format as, or similar format to when we are proving the product rule. We'll consider our function y is equal to u divided by w. We'll consider that there is a small change in the value of x for our graph, and that this small value in the change of x corresponds to a small change in the value of y, a small change in the value of u, and also a small change in the value of w, called delta y, delta u, and delta w. We'll consider what happens when we take the limit as our small change in x, delta x, approaches 0. Now, if we're considering a small change in the value of x resulting in a small change in the value of all of our other variables, we can represent this in our function as such. Y plus delta y is going to be equal to u plus delta u divided by w plus delta w. Now, with the product rule, we could subtract both sides by y and simply cancel out y on both ends of the equation. We'll still be doing the same thing here, but we're not going to end up with any canceling, and because of that, we're going to have to do some manipulation with the fraction on the right here. We're going to subtract y from both sides, end up with delta y on its own on the left. This is going to be equal to u plus delta u divided by w plus delta w, subtracted by y. And in this case, we're going to consider y as being equal to u divided by w. U divided by w. Now, from here, we would like to combine the two fractions on the right-hand side into one singular fraction. We're going to have to multiply the top and bottom of u over w by w plus delta w, and we'll want to multiply the top and bottom of u plus delta w over w plus delta w by w. So delta y is going to be equal to, we're going to have u plus delta u times by w subtracted by u multiplied by w plus delta w. And then all of this is going to be divided by w multiplied by w plus delta w. And there we go. From this point, we can multiply out the brackets in the top and bottom of our fraction. We end up with u times w plus by w times delta u subtracted by u times w, and this is convenient. U times w cancels out of the equation. And then subtracted by u times delta w. And then all of this is going to be divided by w squared plus by w times delta w. Now, from this point, I'm going to take this, and I'm going to put this result up here. We're going to want to do the exact same thing as we did with the product rule. We're going to divide both sides of this equation by delta x, and then we're going to consider what happens as delta x approaches 0. So we're going to take delta y divided by delta x is going to be equal to, now, we're going to have w times delta u divided by delta x, which we can just separate into w times delta u divided by delta x. This will be subtracted by u multiplied by delta w divided by delta x. And then all of this will be divided by w squared plus w times delta w once again. Now, we want to consider what happens when delta x goes to 0. Well, as delta x approaches 0, we know that delta y will approach 0, delta u will approach 0, and delta w will approach 0. From the first principles of differentiation, we understand that this means delta y divided by delta x is going to approach the derivative of y with respect to x. So dy over dx is going to be equal to w multiplied by delta u over delta x is going to approach du over dx. So will be subtracted by u multiplied by, and delta w over delta x is going to approach dw divided by dx. All of this is now going to be subtracted by w squared plus w multiplied by 0, because delta w here is approaching 0. So w times 0 completely cancels out of the equation, and we're left with our quotient rule here. The derivative of y with respect to x is equal to w times du over dx minus u times dw over dx. All of this divided by w squared. Now from here, I would like to differentiate a function using the quotient rule. I'll be differentiating our example right here from the beginning of the video. So we know that our derivative, which I'm just going to call y prime for convenience, is going to be equal to the derivative of the numerator. In this case, the derivative of the numerator is going to be the derivative of 4x cubed minus 8. The derivative of 4x cubed will be 4 times 3x squared, and 4 times 3 is going to be equal to 12x. So 12x squared, and then the derivative of minus 8 is just 0. And then this is going to be multiplied by our denominator, the square root of 9x plus by 1. This will be subtracted by the derivative of the denominator multiplied by the numerator. In this case, the derivative of the square root of 9x plus 1 will be, well, we have to use the chain rule for this. So we're going to do the inner derivative first. The derivative of 9x plus 1 is just 9. Then we will do the outer derivative. This will be multiplied by 1/2 times by, we have 9x plus by 1, and the power reduces by 1. So if we start with 9x plus 1 to the power of 1/2, subtract 1 from that, and we have 9x plus 1 to the power of negative 1/2. And then this will, of course, be multiplied by 4x cubed minus by 8. 4x cubed minus by 8. And all of this is going to be divided by the square of the denominator. And squaring a square root simply means that they will cancel out, and we'll just be left with 9x plus by 1. Now, we can do a little bit of simplification here if we really want to. In order to get rid of this half in the numerator here, let's multiply both sides of our equation by, or both sides of our fraction by 2. We'll end up with 24x squared multiplied by the square root of 9x plus 1, subtracted by 9 times by 4x cubed minus 8, multiplied by 9x plus 1 to the power of negative 1/2. All of this divided by 9x plus by 1. And from here, you could figure out the gradient of this function at any given value of x.